this is the perfect orchestration that you have there. Danny started us high up, and then we did a deep dive into the tech part, and now I'm trying to bring us back up and talk about something that we have been thinking about a lot for the last 2 years, seeing what is going on, not just in the legal world, but in the social science world. Pretty much a heated debate around the use of differential privacy and its implication for social science. And for those interested in reading up on this, it's freely available on the Harvard Data Science Review, this commentary that I'm going to present now. What is interesting is if you follow the debate, those social scientists that have been vocal on voicing concerns about the application of differential privacy, and those that argue with them, it becomes clear pretty quickly that at the core of this disagreement are different beliefs about risks and different beliefs on how to mitigate those risks. So, you know, if at the core, the statistical disclosure limitations, as the name indicates, they want to make sure that they can assess the risk given current evidence. Whereas, as you heard in all the presentations, differential privacy really tries to remove any type of risk, even if we currently can't even imagine what that risk might be. And I think that's very important to keep in mind, because that goes to show that this disagreement cannot really be assessed with evidence. You know, it doesn't matter what data are out there currently that are suited for an attack or whatnot. If your mission is to remove all the risk, even those that comes in the future, then you're just in a different belief system, right? So that I want to post up front for everybody to keep in mind. I do think this is a necessary debate, and it's important that we have it. And it is also important to understand what it means for the social scientists that might feel threatened or uncomfortable by the development that we heard. So for these reasons in this talk, I want to highlight 5 consequences of the applications that we've just gone through the lens of social scientists, and then discuss this a little bit differently with 3 different data types or data use cases in mind. And finally, point to some social science issues and examples that you've seen before, but again, from a slightly different lens, and want to end with sort of open questions, coming back to Danny's call, that there are lots of open questions that he might be able to fund the research on filling. So looking at these 5 consequences for the army of social scientists out there, the first one that I think it becomes pretty clear here is that differential privacy through the randomization and the various algorithm application that you've heard can sometimes create biases when we estimate relationships. And to quote Danny one more time, you know, not here to revoke licenses, but it does mean that social scientists will need to routinely employ measurement error corrections to obtain unbiased estimates. And to the extent that that isn't currently already part of the workflow and they're doing or our doing, then this is certainly a strong implication for the work with these data. Now, you've also seen on the various examples, and in particular, when Ian was just talking about the different university sizes, for example, that there is sort of a precision and sample size issue going on here, and the amount of noise or privacy budget that we have here. For many of the research questions, one can anticipate that social scientists will need to drastically increase the number of people their sample have to achieve both privacy and acceptable powerful tests if they want to test, for example, differences in means between groups. This is not unusual. We have seen this in other ways of social science data collection. Complex surveys have this feature too. We have a trade-off where we, for sample statisticians reason, have certain sampling schemes that enlarge the variance factors and require, in a way, a larger sample size to create the same power. Now, on this notion, though, if you think about social science data collection, and for some of you who are not deeply involved in doing this directly, some figures here, you can sort of guesstimate in, average size length survey in the social sciences to cost about $50 per case when asked via mail, $250 per case, completed case when asked per telephone, and about $1,000 completed case when asked face-to-face. Now that is a lot of money, and so any mechanism, algorithms, disclosure avoidance mechanism that we apply that have an effect on sample size need to have these costs in mind. And I'll come back to this when I talk about the 3 data types. Very early on in this method section, you heard about the Google and Apple and big log tech data applications. There, an individual data point is comparatively cheap. This is a different scale that we are dealing with. So leading me to the third implication, that at least researchers that study small groups may find their current methods to no longer be sufficient, and meaning that they will likely require new research designs with increased costs if they know down the road differential privacy will be used to analyze the data or share the data. The fourth one, the change in workflow, I already alluded to this a little bit, but when I spoke about applying measurement error models, but also one has to keep in mind that pre-processing, data cleaning, and imputation, things that we, at least with data that are collected through primary data collection, such as surveys, often do, they also will drain the privacy budget. And there are still, places that spend months cleaning the data and doing queries and looking for inconsistencies and whatnot. A separate methods debate that we're not going to have today, whether and to which extent that is necessary. There are rumors out for some that there's an issue of over editing. But by and large, for a lot of big surveys, this is an important process, and it requires going back to the original data. It requires iterative procedures. In short, it can, if this is not working on an individual case without showing it any of the other cases, but if it is comparing individual answers to distribution and then fixing, for example, via imputation, missing error problems or missing data problems, then that is something that counts against the privacy budget. If we are not dealing in a sample survey case, then the solution of just increasing the sample size in order to make up for some of the problems or some of the increased variances that we have won't work if we deal with census-like data, because we can't just increase the population. Census-like data, I mean data that have sort of a to us known population of which we have records for everybody. This could be administrative data or company data or what have you, but basically you do analyses on everybody. Which means that for social scientists, we might very well be in a situation where there's a limit to the type of research question that can be answered, which I have to say might not necessarily be a bad thing, right? We have all seen the discussion of p-hacking. We have all seen the debates on questioning, how much should be pre-specified before going into an analysis and how much exploration should be going on. It's certainly a debate that in the light of DP gets a renewed angle. Now, we saw this at the very beginning, and here again, emphasizing that at the heart, differential privacy is about limiting the sensitivity of one's conclusion on the presence or absence of one person in the analysis. And as Cynthia Dwork said, and their colleague said already in 2015, one could just think of it as robust statistics, right? Which, you know, is also a good thing. However, in the workflow that we are used to, outliers can have a very different role, right? So at least in many social science research applications that I've been involved in, outliers often led to the next set of hypotheses for the next set of research that people have been doing, because they realized, okay, there is a relationship, there is an omitted variable that was so far not clear, but now we're going after that and including that. So there are angles and versions of social science research that need to be changed or likely look slightly different in this context. Finally, to release data for general usage with differential privacy guarantees, the party that releases the data must weigh the privacy requirements against the unforeseen usage of the data. Meaning for the social scientists, they will have to be explicit and limit the type and scope and the number of questions they ask of any given data set. We spoke about that before, that the sort of an anticipation of a privacy budget necessary for these endeavors. However, if you think about privacy protecting measures such as GDPR, the General Data Protection Regulation from the EU, that's already in place. There too is the requirement for at least most data collectors to be very specific on what's done with the data and have clear plans, right? So it's not entirely out of scope and out of spirit. In short, if implemented widely, there's no question that this will substantially transform social science, and researchers will need to use more complex statistical methods to account for non-sampling errors, something we probably should already be doing in many cases, and look the other way. Then we will often need to increase sample sizes, in particular if we're interested in small groups or comparing small groups. Then we might to have explicitly limit the scope and the complexity of the research question, and therefore work with more precise research questions. Now, again, I'll leave it to the debate and the discussion, and we might have a couple of minutes for that at the end, whether that's a good thing or a bad thing. But for now, just sort of discussing the implications. I do want to discuss, though, or bring up the questions to the panelists and the audience, if the same protection really is needed and should be planned for, or if different solutions are maybe in order for different types of data. So far, we've looked at, broad, large scope projects as they come out of the US Census Bureau, and it's admirable what has been done there. A lot of social science research, as many of you know, deal with data sets that are much smaller. They are samples of the population. They deal with administrative data sets, large databases that are currently in statistical research data centers, and then increasingly an interest in big data or log data or whatever your favorite term might be. And those likely are quite different in what they need in the handling. So let's look at the sample surveys first. These are the type of data that usually are available right now publicly at no cost. They are publicly funded. One big example is the European Social Survey or the World Value Survey or the General Social Survey. Depending on where you're located, you might have your favorite of those. And of course, panel studies like PSID or Health and Retirement Survey and the like. For these type of data, differential privacy, in our opinion, or in my opinion, representing that here, but on behalf of me and Daniel Bresky, it can probably only hurt, because there's, looking from a social science perspective, no evidence of a privacy risk, surely. One could imagine one that's currently not present, but one has to keep in mind that the sampling itself, or the small sample size we have here, likely creates already a form of protection that might be sufficient for the purpose that we have here. More importantly, though, a lot of these surveys have attitudinal questions in them. And for anyone who studies measurement error, it's probably no surprise to hear that the answers we get to these questions are often not as reliable as we would like them to be. And so it is not necessarily likely that we would get the same set of answers from the same person in a different source and the like. Of course, to the extent that they're behavioral or traditionally called PII data available in those surveys, that's a different story, and I'm only talking about the kind of data as they're released right now, where those are removed. The second set is closest to what the examples were that we've seen here. Confidential microdata of large, sometimes the entire groups, sometimes the entire population, such as a census or Social Security Administration record, tax record, and the like. So far, or still beloved model, is to have trusted researchers that can access the data in a secure computing environment. And they often pass a lot of impressive number of hurdles, and that's exactly the reason why these concepts of differential privacy are in a way attractive, if that were to remove such hurdles to use these data. However, for certain research problems, we have seen, or still experience, as more and more of these administrative data become available, that there is quite a bit of pre-processing still needed, even after data are put into these enclaves, because the meaning and values of these administrative data are often not as well designed as they are in surveys, and only when doing certain analysis, it becomes clear what is missing, what might need to be changed, which feature need to be generated, and doing that on data that are already differentially private might be a whole nother challenge. But as I said, it could be very attractive to think about how differential privacy can be used here in a way that everything that leaves the enclave fulfills the requirements, so that differential privacy is applied to the results, not necessarily to the microdata to begin with. I know that that does not fulfill the strict requirements, because there are people working on these microdata in the enclaves, but it will be interesting to see in the debate if for certain data types such hybrid will be necessary in order to even know what the actual meaning might be of the values that they're looking at. And then finally, data that are generated through the interaction with platform and devices, such as postings on Facebook, to take the prominent example that Social Science 1 is working on, but also geolocation, purchase data, transactions, and the like. Their raw data are out of researchers' availability to begin with. So applying the principles of differential privacy will be of great use for social science research. So despite having to increase your toolkit and learning some other aspects, in this case here, I think there's a big advantage, because it opens access, just like it might increase the speed on the research data science centers to get access here. It will make it possible to get access to data that would otherwise never be available for social scientists to do research on. And so I think that and this is paired with the fact that these are large volumes of data. So the sample size problems we have been discussing before do not apply here. And it's certainly an application area where we can only say the social scientist community should embrace the development of these differential privacy techniques. Now, this all said, privacy itself, we're thinking about privacy, is also a social issue, where it's not just the process of having the data, doing an analysis, and having an output, but we have the people that are providing the data. And one of the big arguments, and certainly when we saw the press releases around differential privacy with respect to the census. One of the hopes too was that, okay, maybe we can have a mechanism, a protection and insurance that will make it easier and more comfortable for people to provide their data to researchers. And Danny was introducing randomized response early on, and then we got a more detailed explanation of it as we went along. But it is interesting to see that, you know, every statistics department I've dealt with, and now I'm learning this is to be found among economists too, everyone loves randomized response technique as sort of a mathematical tool. It's an incredibly charming trick to do, and it's convincing, and you know, I like to teach it when I teach questionnaire design and whatnot. The problem is, in practice, when you try to do it in the field, it actually often doesn't work. And the problem is, as some of the studies that I mentioned here have shown, that people just don't trust the randomizing device. It seems black boxish, it seems weird what happens there. And for an individual respondent, no matter how good the math is behind the technique, the always safe thing is to not reveal the sensitive information, right? Then I don't have to trust the math. I can just lie, right? Then I'm safe. And so there is a false negative tendency, in particular in settings where the questioning happens in a sort of hard to trust build environment. We have seen these cautions shared by a variety of researchers. There's certainly setting in which it works, but there's no guarantee that respondents will be trusting just because the math works out that way. We've also seen this tendency to sort of, you know, see items and topics as more sensitive if we ourselves experience a negative behavior. These are, and as I said, it depends on the mode of data collection. What you see in this chart here is the percent of people that perceive a certain item as being sensitive. And these items were all sort of their college history, whether someone dropped a class, got a D or F, got a put on warning or probation, or has a GPA smaller than 2.5. And those respondents that had, according to administrative record, these things happened to them. You see here their values on their perceived item sensitivity in inactive voice responses where we removed the interviewer, on a web survey, and in a telephone survey. And so the involvement of a person, maybe such person that can explain the randomized response technique, leads to a greater perception of item sensitivity, in particular among those that experience this undesired behavior. Another piece of evidence that it might be hard to sort of change the perception, no matter how we change the technique, are these fantastic surveys that the Census Bureau is putting out for years on sort of beliefs about data being kept confidential in the federal statistical system. It's remarkably stable. And actually, I'm very curious to see, I have this only until 2018, but I need to reach out to Jenny Charles. I believe there are new data on this series, and you know, certainly big shocks like we experience right now might have an effect, but it would be interesting to see to which extent the public perception was already sufficiently there before COVID started, and we only had, you know, the new information about DP being used. Hot off the press, another angle to this, also COVID related. I mean, at the core of it is the question on how willing are people to share information, and are they willing to share this only under these strong privacy preserving protection, or are there situations in which sharing is, how should I put this, more desirable? If you read the work from Helen Nissenbaum, Privacy in Context, or her theory or framework on contextual integrity, you will see that there's the strong argument made that it depends on the type of information, the use put to this information, and who is the recipient in the data, a set of parameters that sort of shape willingness to share, and with that, the need for privacy protection, or in some cases, even a preference for not protecting the privacy, because then, for example, my doctor can help me better in my my medical problems. Now, what you see here, and I only bring this with me because it shows how quickly this can change, again, with trust in sort of data recipient in this case. This is what you see in each chart is the willingness to share personal health information on the left, and the willingness for data to be reused on the right. Data collected by the Wyman Forum. And the data collection happened in March and in June. And compared to March, the willingness to share personal health information remained relatively stable for personal use, but it dropped quite a bit on sort of data being reused to make sure that system information is learned, research is being done, and whatnot. The willingness was very high at the beginning of the pandemic, but then dropped down when in many countries the immediate threat somewhat disappeared. We have seen the same in research we did on pre-COVID and measures of willingness to share health information to fight virus pandemic, and then doing this via COVID. So the context in which this matters, so how important is it that the most accurate data is used and my data is used for a certain purpose, will certainly shape private perception. Now, one more angle on this sort of social science perspective on differential privacy and how well can that work. If you think about typical invitations, here's a survey invitation, we tend to invite participants to join a survey by saying, your answer matters. It's really important that you as an individual contribute. And if we then say the estimate will be the same with or without you, as we advertise the notion of DP, then that's probably not going to fly. Of course, this is an exaggeration. We will not do these in the introductions, but what I think is important to keep in mind that while DP when implemented, will widely change social science research, and certainly can enhance greatly social science research for specific data types, in order to change the public perception, we will likely have to work a little bit more and not stop at the charming techniques. So the public outreach, not just among the scientists, and thank you NBER for creating the forum to do so, to reach a wider audience of researchers, but also to the general public. That will be an important element if we think it is important to get any data release that people understand, or at least trust enough that the data is used a certain way. There are still many open questions. For example, what if data linkage is desired? What if I have a panel survey like PSID and there's downstream data that I don't even know yet, right? What is then the set of data and my criteria for applying epsilon in these kind of panel settings? Similar with other hierarchical data, such as household data, we saw earlier applications where this is starting to being tackled. The general question of how to deal with complex survey samples is one that needs more attention, and we've seen the Census Bureau and others making great efforts to solicit people to work on